Hello guys, how are you today? So today I'll be explaining the chapter 11 qualitative chemical analysis topics. Okay? So here these are all information you're supposed to know. You're supposed to study them by yourself. And then we get over here to the bottom where we reach the properties of the gases. This was not found in chapter 2. So everything above could be found in chapter 2, but the properties of gases were not found in chapter 2. So anyways, we move on to CQD number 1. Here they told us how can you verify the presence of H plus ions in a solution using a pH meter. pH meter will verify the presence of H plus ions by ranking it on a scale between 1 and 14. In between 1 and 14 we have 7. 7 means it has the same number of H plus ions as OH minus ions. If it is greater than 7, it will have more OH minus ions. If it's less than 7, it will have more H plus ions. That's very simply it. So you can say if the pH meter gives a reading less than 7, then it contains a high concentration of H plus ions. Part B, how can you verify the presence of H plus ions in a solution using the materials listed below? Write the net ionic equation for each reaction and report any expected observations. So, first thing we have is sodium carbonate. Sodium carbonate, it is an A2CO3. They said they want to verify the presence of ions, so plus H plus. First of all, what we're going to do is we're going to break these into their ions, so Na plus CO3 2 minus. Definitely the plus is going to take a minus. And we are going to get what? The reaction between CO3 2 minus and 2H plus, because it's not balanced. It will form carbon dioxide gas and H2O liquid. Okay, part 2, a piece of magnesium ribbon will react with H plus, so it's Mg solid will react with H plus, okay, which is aqueous. Now what's going to happen here? If you take the ion of Mg, it's Mg2 plus. Because they are both positive, they are going to substitute each other. So the aqueous will become a solid, liquid, or gas, and the solid, liquid, or gas will become aqueous. So it will become Mg2 plus aqueous, okay, plus H2 gas. We move on to part C. In part C, they said, how are the ions of lithium, sodium, and potassium identified? We use something called the flame test. Lithium has a crimson red color, which means deep red color. Sodium has a yellow or orange yellow color, and potassium has a violet or lilac color. We'll move on to part D. A flame test is conducted on a sample of calcium chloride. What color will the flame have? First of all, calcium chloride, it is CaCl2. You break it into its ions, Ca2 plus, Cl minus. So the one that will give us a flame, it is Ca2 plus, and it will give us a brick red flame. We move on to part E. How can you test for calcium ions using a concentrated solution of sodium hydroxide? Okay, you're testing for calcium ions, which is the Ca2 plus ions, in the presence of sodium hydroxide, NaOH. Okay, now what you're going to do is you're going to separate these into their ions. So you have Na plus and OH minus. So because this is positive, it's going to take the negative and not the positive side of the equation. So it will become CaOH2. Now this, it is insoluble in water, so it will form a precipitate. So it forms a precipitate. PPT means precipitate. So Ca2 plus, 2 plus aqueous, in addition to 2OH minus aqueous, will form CaOH2 solid. That is it for CQD1. We will now move on to CQD number 2. In CQD number 2, they said, how can you test for the following ions using sodium hydroxide in an ammonium solution? So what we need to know is that Al3 plus, when it will react with NaOH, it will give us what? It will produce a white precipitate that is soluble in excess. Okay? However, if Al3 plus will react with ammonium, which is NH3, it will also produce a white precipitate, but this white precipitate is insoluble. I don't know what I wrote. Insoluble in excess. Okay? Whereas for the Zn2 plus, okay, it is gonna be Zn2 plus. When it reacts with NaOH, it is gonna give us a white precipitate that is soluble in excess. Whereas when it reacts with NH3, it will also form a white precipitate that is soluble in excess. And that is it for CQD number 2. We move on to CQD number 3. In CQD number 3, they said, how can you test the following ions using sodium hydroxide solution? Write the net ionic equation and report the expected observations. So what's going to happen is that you're going to add NaOH to each of these. Okay, and it's going to form a product. And each product has a different color because, again, we're dealing with Fe2+, Fe3+, Cu2+, and Cr3+. So the net ionic equation, it will always be what? It will take, these are first of all positive ions, and sodium hydroxide, it's NaOH. You split it into its ions, you have Na plus and OH minus. So they will take the negative. So they will all react with what? With OH minus. And of course, you have to balance it later, okay, to produce different products, okay? The first product that we have, it is when Fe2 plus will react with OH minus, okay? And it is gonna produce the product, which is FeOH2 solid, and it is a dirty green precipitate. To balance it, you are gonna put a 2 over here. So I'm just gonna put a 2OH minus. When we are reacting with Fe3 plus, Fe3 plus will react with OH minus to produce FeOH3, which is a precipitate, but it's a red-brown precipitate. And to balance it, you're gonna put a 3OH minus. For the Cu2 plus, when it reacts with OH, it's gonna produce the precipitate, which is CuOH2. So it is a solid and it is a pale blue precipitate. To balance it, you're going to put a 2OH minus. And now finally, when you're reacting Cr3 plus OH minus, it will produce CrOH3, which is a solid. And its color is a green precipitate. And I think this precipitate is the only precipitate out of all of these three that dissolves in excess. Okay, and to balance it, you're gonna be putting a 3OH minus. That is it for CQD number 3. We will now move on to part B of CQD number 3. In part B, they said, how can you test for copper ions using ammonia solution and report the expected observation? No equations are necessary. If you use the copper ions, which is Cu2 plus, and you use the ammonia solution, NH3, it will form a light blue precipitate that dissolves or that is soluble in excess, forming a darker solution. Okay, we now move on to, so now CQD number 4. How can you identify ammonium ions using a solution of sodium hydroxide? When ammonium ions, which is NH4+, reacts with sodium hydroxide, NaOH, okay, it will produce ammonia NH3. To test this gas, okay, it will give out a pungent smell, okay, and it will turn moist red litmus paper blue, okay? Now, if they want the ionic equation, it's gonna be like this: NH4 plus OH minus, always remember the positive will react with the negative to produce NH3 gas plus H2O liquid. That is it for CQD number 4. We now move on to CQD number 5. Here they said, how can you verify the presence of OH minus ions in a solution using a pH meter? Same thing. The pH meter is a scale from 1 to 14. If it is in the middle 7, it has the same number of hydrogen ions as OH minus. If it is more, like if it's less than 7, it will have more H plus. If it's greater than 7, it will have more OH minus. So very simply, if the pH meter gives a reading greater than 7, then the solution contains high concentration of OH minus. Okay, part B. How can you test for the following ions using silver nitrate solution? Okay, we're using AgNO3. So the Ag, it will react with DCl minus to form a white precipitate. Okay, Br will react with the Ag, or Ag will react with the Br minus to produce a creamy precipitate, and the I minus will react with the Ag to produce a yellow precipitate. So, anyways, we'll move on to CQD number 6. In CQD number 6, it says, how can you test for the following ions using hydrochloric acid HCl solution? They want us to write the net ionic equation and whatever. Okay, so again, I'm not going to be writing the net ionic equations because you guys probably know by now how to write them. You're just going to use the ions that are reacting to form the products, okay? So we're going to take the H plus from the hydrochloric acid because as you can see, they are all negative. So the H plus, which is the positive ion, it's going to be reacting with these. H plus reacts with CO3 2 minus to form carbon dioxide and liquid water. So carbon dioxide gas and liquid water. It reacts with hydrogen carbonate to form also carbon dioxide gas and liquid water. And then finally it reacts with SO3 2 minus to form sulfur dioxide, SO2 gas, and liquid water. Okay, so now we move on to CQD number 7. How can you test for the presence of SO4 2 minus ions in a solution? Again, to test for the presence of SO4 2 minus ions in the solution, you are going to add something with Ba2 plus. For example, you could add barium nitrate, which is BaNO3 2. You will add it to the SO4 2 minus, and if it will produce a white precipitate, this white precipitate, it is BaSO4, then you know that there is the presence of SO4. For part B, they said write the net ionic equation for the reaction that will take place when sodium sulfide, Na2S, react with PbNO3 aqueous. What observations are expected in this case? So we are going to have PbNO3 reacting, NO32 reacting with Na2S. Let us divide them into their ions. If we divide them into their ions, we will have Pb2 plus, NO3 minus, and then Na plus S2 minus. You will join the positive with the negative and the negative with the positive, and you will get two new compounds. They are NaNO3, which is soluble in water, so it will not form a precipitate. However, you will get PbS. Now, PbS, it will form a solid precipitate, so the observation observed, it is PbS, which is a precipitate. Now we move on to CQD number 8. They said, describe how each of the following gases are tested. Write an equation for the expected reactions where applicable. So H2 gas, its test is a lit splint. Oxygen gas, its test is a glowing splint. NH3 gas, its test is a damp red litmus paper. Carbon dioxide, it's lime water. And then chlorine, it is damp litmus paper. Okay, and then finally sulfur dioxide, it is acidified potassium manganate. Now, for the observation, the reaction where applicable, first of all, we know that if it acts with a lit splint, it will explode the lit splint, or there is a popping sound. With a glowing splint, if there will be a relighting, it will relight the glowing splint. Now the ammonia will turn damp red litmus paper blue. Carbon dioxide will turn the lime water milky. Okay, and a reaction of this, it's gonna be that the CaOH2 which is lime water, will react with CO2 gas to form what? To form limestone, which is CaCO3, which is what causes the milky appearance, plus H2O liquid. So again, the calcium hydroxide, which is the lime water, you add to it carbon dioxide, it will form a limestone, which is the reason for the milky appearance. Cl2, it will turn the damp litmus paper bleach. It will bleach the damp litmus paper. However, blue will turn red, then it will get bleached, but red directly gets bleached. And now finally, acidified potassium manganate, it will decolorize the purple solution. Okay, we go down to CQD9. They said, identify the unknown gas from the given observation. A yellow-green gas with a choking smell that bleached a moist litmus paper. This is chlorine gas. Relights a glowing splint. This is oxygen gas. A colorless, odorless gas that makes a pop sound when approached by a light splint. This is hydrogen gas. A pungent smell directly. We know this is ammonia gas. E, it will turn lime water milky. This is carbon dioxide gas. And then finally, decolorizes a purple acidified aqueous potassium manganate. This is sulfur dioxide gas. We now move on to CQD number 10. And CQD number 10, they said, how can you test for the presence of water in a sample of colorless liquid? Write an equation for the expected reaction. You could add, for example, anhydrous, copper, disulfate. When you add the copper disulfate, it will turn from white to blue, and just like that, you know there is the presence of water. Or you could also use the anhydrous cobalt chloride, and it will turn from blue to pink. Okay, that is it for CQD number 10. We move on to CQD number 11. And CQD number 11, they said, how can you distinguish between hexane and hexene, both of which are colorless liquids at room temperature? Okay, this is very important. Hexane and hexene. First of all, hexane, it is what? It is an alkane. Hexene, it is an alkene. Now, alkane, if it will react with bromine, there will be no effect. However, alkene, when it will react with bromine, it will decolorize it. So it will decolorize. So how to know the difference between hexane and hexene? Hexene will decolorize the bromine, whereas the hexane will not decolorize it. We move on to CQD number 12. Top, a student is asked to identify two salts, T and W. A student noted the following observations while testing salt T. Solution of salt T forms a white precipitate with sodium hydroxide, and the precipitate does not dissolve upon adding excess sodium hydroxide. Directly, we know that this is, first of all, Ca2+, calcium. Okay, however, solution of T forms a yellow precipitate with acidified aqueous silver nitrate, so this we note is I-. So the cation is Ca2+, the anion is I-, the compound it is CaI2. We move on to part B. The student noted the following observations while testing salt W. Observation 1, salt W gives a red color in a flame test. So for part B, the student noted the following observations while testing salt W. Observation 1, salt W gives a red color in a flame test. If it will give a red color in a flame test, then for sure it is Li+. If they told us brick red, then we know it is Ca2+, okay? Now they told us solution of W releases a gas that turns blue wet litmus paper red upon the addition of dilute hydrochloric acid and gentle heating. So whenever you see it turn blue wet litmus paper red, that means it definitely released. We know that this ion, it is SO3 2-, okay? So the cation of salt W, it's Li+, the anion is SO3 2-, and the salt, it is Li2, SO3. Now describe how a flame test is done on a sample of salt. First of all, we will get a platinum wire, okay? You will clean it by dipping it in what? In acid. So you dip in acid to clean. Okay, and then after we dip it in an acid to clean, you will put it in the Bunsen flame. Okay, after you put it in a Bunsen flame, you will see that it will give you, before you dip it in the Bunsen flame, you should have dipped it in the acid. Now to check if it's clean, you will put it in the Bunsen flame and it will not give any color. Then you dip in solution and you put in flame and then it will give you the color. Now that is it for this CQD. We move on to CQD number 13 top. Here they told us, a student was analyzing two solids A and B. Solid A is zinc iodide, but solid B is unknown. Tests on solid A. Solid A was dissolved in water and the resulting solution was divided into 3 test tubes in equal proportions. First proportion, because first of all we know it is zinc iodide, so it is ZnI2. Okay, so a few drops of aqueous sodium hydroxide are added. How does zinc Zn2 plus react with NaOH? It will form a white precipitate that is soluble in excess. Okay, now an excess of aqueous sodium hydroxide was added to this mixture. Again, in excess, we said that it is also soluble. So a white precipitate that is also soluble in excess. Now, a few drops of ammonia are added. Again, here, a white precipitate forms. And again, it is soluble in excess. So it's just going to be like a white precipitate that is soluble. So it's a colorless solution. Now the third portion, there is aqueous silver nitrate, so AgNO3. What will the I do? It will react with the Ag to form a yellow precipitate. Okay, so that is it for solid A, for CQD number 13 top. For solid B, they say tests on solid B. After dissolving solid B in water, the following observations were recorded. So they did sodium hydroxide, they got a pale blue precipitate. Pale blue means directly that this is Cu2+. And then aluminum foil, whenever you see aluminum foil, you will directly know that this is NO3-. So you do the crisscross and you will get that the chemical formula for solid B is CuNO3 2. That is it for CQD number 13. We now move on to CQD number 14. Here they said that a student analyzed soluble carbonate salt R. No observations were recorded when the carbonate salt R was slightly heated in a test tube. What does this indicate about salt R? This means it is not hydrated. So if nothing happens when heating it slightly, that means there is no water in it, so it's not hydrated. Part B. Salt R was dissolved in water and divided equally into 4 test tubes. The following test tubes were conducted on tests were conducted on the test tubes. Complete the observations for each of the following tests. First of all, test 1. A small amount of dilute hydrochloric acid was added to the first test tube. The mixture effervesces, producing a gas. This gas, okay, we will need to figure out what it is. The gas released was bubbled in lime water solution. So the observation is that lime water turned milky. However, the gas released, it is going to be then carbon dioxide, because if lime water turns milky, then it is carbon dioxide. Now part C. So now we move on to part C. 2 more tests were conducted and the following observations were recorded. We have test 3. To a new test tube of solution, dilute sodium hydroxide was added. Okay, the mixture was then warmed carefully. Observations, effervescence, pungent gas, that means it's probably NH3. Ammonia, and yeah, for sure now after we read this, that means it's ammonia. But since they reacted it with sodium hydroxide, that means for sure that the gas, it is what it is, NH4+. The ion present, it is ammonium ion, which is NH4+. Why did the damp litmus paper turn blue? Because we have a basic gas being released. Okay, and then identify the gas released. It is probably NH3, which is ammonia. Now, they told us, write the chemical formula for salt R. We found the gas up to be CO2, and the ion that gives us CO2, it is CO3 2 minus. Here we know that the ion, it is NH4 plus, so it's gonna be NH4 plus and CO3 2 minus, so it will be NH4 2 CO3. Okay, now for part E, why is it necessary to warm carefully the mixture in test 3? Explain your answer. Because first of all, NaOH, it is hazardous, very toxic. Okay, and the boiling may allow it to spit. So that's pretty much it for this topics 11. Thank you guys for watching. I hope you enjoyed and have a wonderful day.